Good morning. For this assignment, you will be performing various vertical and horizontal shifts on different functions. So you notice this first one is a vertical shift and the second one is a horizontal shift. You can tell because if the addition or subtraction is grouped with the x, you can tell it's a horizontal shift. For example, these first few are vertical shifts, and these down here are horizontal shifts. All right. So I'm gonna just show how to do one vertical and one horizontal shift. So this first one is log base 2 of x plus 1. So this is shifted up 1. So in order to shift this function up, first I check the parent function for logarithms. Notice it has an asymptote at x equals 0 and these points 1, 0. And in this case, it'll be a1 or 2, 1. So, and then here's the domain and the range. So again, vertical shifts only affect y values. So I'm going to go over here, right here. And then, so first, let's see. First, start with the important points. So I think the points are originally at, the point is originally at 1, 0. So since I shifted up 1, I changed the y value to 1. The other value is 2, 1. That's the parent function. So then I shifted up 1 to 2, 2. Then I have the asymptote at x equals 0. Since that's an x value, that stays the same. Same thing with the domain. Again, goes from 0 to infinity. And that stays the same. And the range is all real numbers. So that is the y values. However, since it's all real numbers, it still is all real numbers. So notice for this one, actually not a lot changes about the function. So if we try to graph this out, first I graph out the points 1, 1 and 2, 2. I graph out the asymptote, that's at the same place. And so it simply shifted up 1. Now, note asymptotes and things like that can change, but sometimes they don't. And I wanted to have an example where essentially the values are the same. All right, so those are the values for that. Now for the horizontal shift, so remember it's in the opposite direction than you'd assume. So since it's plus 3, you shift to the left 3. So the x values, you subtract 3 from them. So again, I check the parent function. What is it again? Oh, for square root. I take these points for square root, 0, 0, 1, 1, 4, 2. I'm going to subtract 3 from the x values. Same thing with the domain. I'm going to subtract 3 from the domain values. All right. So, important points. Again, the point 0, 0. We subtract 3 from that, so it becomes negative 1, negative 3, 0. The point 1, 1. You can becomes negative 2, 1. And again, you could change that right away, or you could write the parent function number first and then change it. So 4, 2 would become 1, 2. So everything shifted to the left. 2, there's no asymptote, so I go to domain. I think domain is usually 0 to infinity. So if I subtract 3, I get, with a bracket, negative 3 to infinity. And the range will stay the same since those are the y values. Range goes from, still goes from 0 to infinity. If you want to use infinity symbol there, that's fine. So now that everything is shifted over to the left 3, I can just graph it out and check if the domain and range is correct. Okay, so domain is left 3. So 3, negative 3, 0. I have negative 1, 1. Oh, wait, I think that's a typo. It should be negative 2, 1, shouldn't it be? Because it's 1, 1, you subtract from that and you get 2, 1, negative 2, 1. Okay, so let's graph that out properly. Negative 2, 1, and 1, 2. That's right here. Okay, so if we graph that out, it goes through all those points, and that's our graph. And again, it shifted to the left 3. And that's the process. So first you start with the parent function, determine which direction you're shifting it in, and write out your important points, asymptote if there is one, and domain and range, then graph it out. All right, well, please ask if you have any questions on that. Just do your best, and I will talk to you next time. All right, have a good day.